And so they were using OpenAI for this, but it was very quickly getting out of hand in terms of cost. It's very true that fine tuning actually can improve quality even above the strongest models out there. Once something is critical enough to the business, like even the most minute optimizations drive disproportionate upside. I'd say that Llama is probably still the most popular model, and we actually do keep track of that. It's probably like 60% or so of the fine-tuning jobs are Llama. I definitely think is probably underrated in a lot of ways. RFT is another name for this reinforcement learning with verifiable rewards process. The reward function is definitely the biggest bottleneck, I'd say. That's where you spend like 80% of your time. And one idea that I thought was quite cool was we did this thing on writing CUDA kernels with using RFT. I don't think we're going to have a future where there's one best model that is just everyone uses it for everything.
What do you think is the number one pain of enterprise AI adoption? What if you could fine-tune your own custom state-of-the-art models with just 20 training samples? Today, I'm talking to Travis Addair, CTO of Predibase, which is a platform for fine-tuning and serving custom LLMs at scale, including LLaMA and DeepSeek models. We will dive into when and how companies should fine-tune their own models and how RFT or reinforcement fine-tuning will change the game. Travis will drop a ton of wisdom, so hope you enjoy. And if you're new to the channel, consider supporting my work by liking and subscribing. I'll be creating a lot more AI for business content. Now, let's get into it. Before we start, could you tell us about yourself and your journey from working at Uber to getting the inspiration to co-found Predibase?
Yeah, for sure. So as you mentioned, I was working at Uber a number of years back. I was there for about 4.5 years and worked on the machine learning platform group there, which is called Michelangelo. And specifically, I was leading a team there focused on building deep learning infrastructure. And it initially started with self-driving cars and working on perception models for those. And over time, we started working on more things like customer support automation, Uber Eats recommendation systems, and building out the foundational infrastructure for training those models, serving those models. And along the way, we built a lot of open source technology as well. And a friend of mine slash colleague at Uber, Piero, who was working on the research group, we decided to start this company around 2020 with the idea of taking a lot of the foundational technology that we were building on the open source side to make AI more accessible and bring that to a broader audience. So specifically thinking about organizations that were sitting on a lot of text data or image data and were wondering how they could use it to improve their business and improve their products, but didn't have AI researchers that knew how to write PyTorch and build custom neural networks and things like that. We're looking to bring that technology to those people through like declarative and low code interfaces that could make it a lot more accessible.
It sounds good. So I know that declarative ML is one of the biggest differentiation about Predibase. But I know you guys also started out with a low code open source project. So could you just tell us about that real quick and how you guys decided to focus and go all in on LLM training stack, I guess around 2023? Could you just tell us about that crazy time and where you guys really said, okay, we got to focus on LLMs now?
Yeah. So as you said, like the first version of our product was a low code tool for fine tuning and serving deep learning models like BERT classification models and things like that for folks in the audience who are familiar. And at the time, we were working a lot with engineering teams and things like that that were looking to productionize some of these systems. One thing that I thought was interesting, though, looking back, was that around 2021, 2022, we would go to these larger organizations and say, hey, you have a lot of text data, you have a lot of image data, you should be using deep learning because a lot of these traditional methods don't really know how to make use of that data. And they would say, I don't really care about that. Can you give me XGBoost? Can you give me something that understands tabular data? And I think the biggest shift that happened as a result of ChatGPT was really this awakening of interest in these sorts of NLP use cases, like situations where you have raw text data and you want to do something interesting with it. So what really changed for us was when Llama came out a few months later, in 2023, that was the first time there was a real open source model that uh, was competitive with what some of the foundational models, like what OpenAI was doing, was available. And people already were finding ways to fine tune it and customize it to specific tasks. And we quickly identified that this was very similar to what we were already doing, but with predictive AI. So, from a technology standpoint, I think there was already a lot of synergy there. But now the types of use cases that people were applying it to were oftentimes different, like generating text or chatbots and things like that. But for us, the reason why we were interested in fine tuning, apart from the fact that it was already very synergistic with what we were doing pre-LM, I would say what really stood out to me is just that when I looked at these foundational models like GPT-4 at the time, what I noticed was that they were these big, massive sledgehammers that could do a lot of things and were very powerful, but also very heavyweight. And my thinking is that if you're building like a B2C product, like I think ChatGPT is the B2C product for OpenAI, right? That these general purpose models make a lot of sense because you don't really know what any one person's going to want to do with that technology. But for enterprise use cases where you want to embed this technology into a specific part of your product or like your core infrastructure, something like that, you don't need it to be this big like general purpose model that can do anything. Like you need to be very good at something very specific, right? And I think there's always a trade-off, right? Whether that's you're compromising on quality for your specific use case or speed because the model is very big and therefore it's just going to take longer to give you a response or cost, it doesn't come for free. And so our idea was let's find these use cases where these things are very critical and help people build customized fit for purpose solutions that solve their exact use case and solve it as well as can be solved and try to offboard people who are exploring the generative AI like, onto this type of paradigm through Predibase.
Speaking of use cases, I talked to a lot of people, and even 2 years after ChatGPT, people are still not totally clear on when they should be fine tuning models and when they should not be doing that. And a lot of people start out with the frontier models from OpenAI, but then they realize they can save a lot of money. But let's talk about some like concrete use cases that you've seen that you could share, and maybe walk us through a typical end-to-end scenario, something that could really resonate with most of the people listening.
For sure. Yeah. So we work with a lot of customers that have a very similar journey, which is they start by using an API service like OpenAI, but then they run into some kind of wall, right? Whether that's quality, like the model doesn't know my data well enough for my use case, whether it's speed, like the response latency is just too high for my end users, or whether it's cost, like as I scale this up, my bill's just going to get ridiculous. One good example is a company called Conversa that we work with. So they're in the customer service call center technology space. And so their use case that we work with them on was real-time information extraction and summarization based on these call transcripts that are coming in. They want to be able to extract metadata, summarize, and so forth. And the challenge that they had was they had something like 60 different use cases that they wanted to operate on, like in terms of like pieces of metadata they wanted to extract, and they all had a different kind of prompt that they needed to apply. You can imagine like a call transcript comes in, you want to extract some metadata, who's the speaker, and various things like that to be able to get like semantic information out of just like a stream of what is originally usually audio, but then eventually gets turned into just like a huge text transcript. And they have like millions of these calls coming in from hundreds of customers every month. And there's like a pretty large amount of volume as well. This is like a real-time use case in the sense that data is constantly flowing in and they need to be able to scale up and accommodate that. And so they were using OpenAI for this, but it was very quickly getting out of hand in terms of cost and also being able to keep up with the of recruiter coming in terms of latency. I think the biggest one though that I think is interesting is that also quality was even a concern for this use case. And so what we ended up doing with them was fine-tuned over 60 what we call adapters, so like these very task-specific models that are just this small number of parameters on top of the original model that was able to drive up significantly higher accuracy. So we had about nearly a 10% boost over OpenAI's best-in-class models on these use cases on average. And what I think was also very interesting is that the way our serving architecture is set up, we were able to serve all of these on a single base model deployment through a serving stack we wrote called Lorax that can serve like hundreds of different models at once on a single GPU. And ultimately led to much higher throughput than they were seeing before in their existing solutions. And I think this is not an uncommon pattern we see either. It's like lots of companies, I think, start off with these foundation models and realize that I can actually improve not just cost, but speed and quality as well, which I think the last one in particular is sometimes maybe surprising, but it's very true that fine tuning actually can improve quality even above the strongest models out there.
It's interesting that you mentioned some of the motivators outside of cost, because if you just focus on cost, all these foundational model companies are, lowering their cost to because of the competitive landscape. So there has to be additional motivations for you to do these fine tunings.
Yeah, well, I think cost is definitely a problem of scale. It's not like a problem that hits you from the beginning necessarily, but there are like some problems that are actually like hard constraints on your ability to productionize something. And I would say those are typically quality, speed, and governance. And for example, if there's like a system that's making a critical diagnosis or something, or like where accuracy is critical, you can't afford to have hallucinations. You can't afford to have the model make mistakes. And so the accuracy bar is very high in those cases. And that's one area where we definitely think fine tuning is useful. Another area is speed, and this is often for the end users, right? Is if you have a real-time application that you're building where your user comes into your app, they click a button, they get some response back from the server. There's often a limit on how slow that can be before the user just stops using your product entirely. And we often talk about LLMs as having responses on the order of seconds in a lot of cases, but that can be prohibitive for certain UIs, right? Like where you need sub-second latency, like 100 millisecond, 10 millisecond latency, right? So speed is another one. And governance as well. I mean, I think treating a model as an API is fine for certain applications, but if the data is very sensitive, we have a lot of customers that have very hard constraints on where that data can live, where it can be sent to, where the model can reside. And that's something we can also help with is putting those deployments into VPCs so that nothing ever leaves the customer's environment and everything stays isolated.
Let's talk about like how you achieve faster latency and obviously privacy. So are you achieving that by deploying these models closer to the customer's environment? Is that the mechanism how you get faster time to first token, or is it some other mechanism? So is there like something extra that you guys are doing to achieve much faster sub like 100 millisecond latency?
Yeah. So there are a few different ways. One is definitely through the VPC deployments. A model that we run in their VPC, we can do direct ingress to that deployment. So everything just goes from VPC to VPC, no traffic flows outside. And so you can get very fast latency that way. But I think more critically, I would point to the fact that if you're fine tuning, you can go from a model that's like hundreds of billions of parameters, and that comes at a certain latency cost. And through fine tuning, you can actually get better quality on a model that's, say, 8 billion parameters instead, right? And by doing that, you can have these order of magnitude increases in speed that come with that. So if you do the work to fine tune through a platform like us, that implicitly is going to confer these latency benefits. The other aspect to it is we do some custom work on the fine tuning side as well that can enable faster serving and higher throughput in production. One example of this is a technology that we developed called Turbo LoRa that we wrote about last year, and it's now generally available in our product. But the way it works is you can train a model not just to be able to improve its quality, so improve the quality of its response, but also to be able to train this additional component that predicts not just the next token, which is what LLMs usually do, but predicts the next three tokens, let's say. And if you can do that, then you can get like theoretically up to 3x faster inference just by being able to predict multiple tokens at a time. And so that's another thing that we offer as part of the product that's a unique capability that comes through fine tuning that then gives you that speed boost once you go to production.
Between build versus buy, what would you say are some of the decision variables that you've seen that the CTOs at these companies have to deal with and eventually make a decision to go with Predibase or any other ISVs? Like what is going through their minds when they eventually decide, okay, we need to move faster, or like what are some of the considerations?
Yeah, the way that I think about it is if you're like, because I, as a CTO, also make these buying decisions about other products as well for build versus buy. And I think that if you're in a high growth, high competitive market where you're under pressure to figure out your Gen AI strategy to execute quickly on deliverables, unless you are pretty confident that you're going to be able to build something on the platform side that is differentiated and best in class, I don't know why you would ever want to build your own platform for doing this sort of thing, because things, as you said, move very quickly. And you have companies like us that are only doing this and trying to do it very well. And the price that you pay is definitely going to be much lower than the cost of hiring a huge team of people to try to build this and maintain it for the next 10 years. So I definitely think it makes sense to buy, unless you're like Google and have some very differentiated ideas on what a platform should look like. And then in terms of making a decision about whether you want to use Predibase or someone else, I think that's one of those cases where it definitely comes down to what you're trying to do. And I think some of the capabilities that we have on particularly the reinforcement fine tuning that we've been working on most recently, we've put a lot of effort into making sure that our platform is not just giving you raw infrastructure, but we're actually helping you get the tools needed to get the best quality models out the other side and get those models into production. So it's not just a matter of, hey, we're going to give you some self-service thing to train with, or we're going to give you fast inference. We think about the end to end and we think about the flywheel that exists where you want to train a model, you want to serve it, you want to collect some usage data, you want to retrain over time. That whole life cycle is something that we try to manage and optimize for. And we think that that's something that we do very different from how a lot of other companies think about this problem.
Let's talk about that privacy and the on-prem deployment specifically. Typically, how long does that whole process take end to end? If you were to take, obviously, I don't know how Predibase or similar ISVs onboard customers. And so are you guys basically putting a copy of the model that you fine-tuned into the customer's VPC?
Yeah, good question. The way that we do our VPC deployments is we have what we call a hybrid deployment model. So we have a centralized control plane that lives in our environment, in our cloud. And then we have a localized data plane for the customer that lives in their VPC. And the separation between those two components, the control plane handles the orchestration, submitting the training jobs, monitoring their progress, handling updates to the state and tracking that state. It also handles all metadata, so like metrics and telemetry and things like that, keeping the record of what jobs have been run, what their current status is, etc. But everything that is sensitive, everything that is training data or user data or customer data, that all lives in the customer's VPC. If the user has their training data set, like in an S3 bucket somewhere, there will be a pod that runs inside the user's VPC environment that reads that data securely, processes it for training, and then discards it. So nothing has ever persisted on our end. Nothing ever goes back to the control plane that's customer data. And then similarly for inference, we write out the model weights to like an S3 bucket in the customer's environment. So again, it's all localized to them. And then when you go and deploy a model, you again spin up another pod, and that pod is going to read those weights that reside on that local S3 bucket into memory to then like load that model and start serving requests. And then all requests can flow directly to that server. So again, nothing ever escapes your environment. So you don't have to worry about if customers are sending PII or something. All of that's going to be entirely contained in that VPC.
Going back to the idea of build versus buy, what do you think is like the number one thing that all these enterprises perhaps underestimate when they try to build this type of an infrastructure for full fine-tuning and productionizing these models all in their own infrastructure? What do you think is the most underrated and the most difficult challenge?
Yeah, I think that doing something once is not that hard. Doing it repeatably and at scale, that's what's hard. So, for example, if you want to just train one model, like you can go download some code from Hugging Face and run a notebook and get a GPU and EC2, and you can probably figure out how to do it. And then similarly, if you want to serve a model, you can go download open source VLM or Lorax and spin up a pod, spin up a container that's serving that model and send it requests and whatever. So I think that part's not hard. But let's say you want to have multiple replicas. Let's say you want to have SLAs on your deployment. Let's say you care about cold start times and being able to go from one to 8 to 4 replicas and being able to manage those costs efficiently and thinking about running multiple train jobs and tracking those experiments and making sure they don't fail and making sure that the quality is as good as it can be. I think those are things that, from an infrastructure standpoint, are non-trivial to figure out. And at that point, it's something where you're going to need a whole team of people that are working on this and constantly keeping abreast of what's changing in the industry. It seems every week we have new techniques on the serving side. Who's responsible for doing the A/B test of saying, let's try this new technique and see if it works? And is it compatible with our existing stack? Do we need to update all our dependencies? It's just a big maintenance headache. And we see this that even with some of the larger organizations that I keep in touch with folks there, they're thinking about what's the future of our machine learning platform? Do we want to just standardize on something that's industry standard as opposed to trying to build it in-house for that simple reason of things are moving very quickly. And unless you have some reason to be doing it, just taking open source code and running it yourself is probably not the most cost-effective solution.
So this is just a personal anecdote, but I know a Fortune 100 company that spent 7 months trying to build out a GPU cluster with all these features that come with like fine tuning and inference, only to scratch all of that. And they even tried to pre-train their own models, spent about $20 million doing it. But it's extreme. I think a lot of people underestimate how fast the industry changes. And I think it's the speed that kind of puts a lot of these technical investments at risk, right? So you have to be aware that a lot of these bets are not similar to the ML, projects of 3 years ago, where you had much longer life cycle of these software projects. Would you more or less agree with that statement that it's a lot riskier now versus, let's say,
Sure.
pre-LLMs?
Yeah, I think the velocity point is really key, right? Because to your point, data science used to be this R&D division where it's like, oh, let's just try a bunch of things and 99.9% of it is going to go nowhere. But if we don't do this, then we won't look good to our board and so forth and our shareholders. I think it's very different now where there's real expectations, right? It's like people are actually shipping real products with AI and they're doing it very quickly. Like they're doing it on the order of weeks and not years anymore. And so to your point, if you're getting hobbled down by the fact that you've only invested a small team of people on building out all this infrastructure and things are moving very quickly, there's a good chance that you're going to get left behind in the process. And even for a company like us, where this is all we do, and we have an entire team of people that have been doing only this for 4 years, it's still a struggle to keep up sometimes. It's almost like a full-time job of mine just to make sure that I'm reading all the papers and making sure that I'm aware of what everyone's doing in this industry so that we can make the right bets on our side about where things are headed. So yeah, I definitely don't envy someone in a position where they're trying to build this all with a much more hobbled setup.
Let's switch gears to the state of fine tuning right now as an industry. A lot of techniques are coming out all the time, which is, I think, part of the reason why it's so hard to keep up with all these fine tuning techniques and inference techniques. Obviously, DeepSeek came out like a month ago. And just stepping back, have you seen any uptick in customer interest in fine tuning because of DeepSeek, or is it just Substack or Twitter hype? Is there any substance to, is this driving any enterprise interest into fine tuning?
Yeah, I definitely say it is. I think DeepSeek interest comes in a few different flavors, right? There are some people who are interested in DeepSeek because of the fact that it's the first time from their perspective that it seems like an open source model has come out that could legitimately displace the top frontier models, right? In terms of being good enough to just move off of those and onto open source. So there's people that are interested in just purely DeepSeek itself. There's also people that are interested in fine-tuning DeepSeek because it's a strong model, like maybe we can make it even stronger if we customize it to our data. And then there's also people that are just interested in the techniques that they use to do their fine tuning. So in the paper that they wrote, they also talk about a model called DeepSeek R10, which was like a pure reinforcement learning based model. And there's been a lot of interesting reproductions of that work that show that you can elicit this very interesting, what they call aha moment, where you can teach the model just to learn how to reason from first principles, more or less. And that's something that we've seen actually be effective as well. So I think there are people that are very curious about DeepSeek in particular, but I'd say probably the quick summary, in my opinion, is that I don't think DeepSeek as a model is going to have a lot of staying power just because models themselves, there's always new models coming out and things are always evolving. And I definitely don't think you want to have be married at the hip to a particular model. But I do think what DeepSeek did was really reveal that one, open source is the future. These foundational models don't really have any real moat, and the gap is closing quickly in terms of what open source is able to do to be competitive with them. And additionally, I think it really showed that there are new paradigms that are emerging in terms of how you can fine-tune these models that are enabling some new use cases and capabilities that previously weren't possible. And we're definitely seeing a lot of people interested in using the DeepSeek method, so to speak, of fine-tuning through reinforcement learning for their use cases.
So like in terms of the state of fine tuning right now, is Llama still the king, or I guess is it still the most popular base model to fine tune simply because it is a US based model? Do you think there's any element of nervousness around the fact that DeepSeek is not an American? I agree with you that it's not like fundamentally changing. DeepSeek doesn't fundamentally change the aspect of that there will be multiple competitors in this space. But yeah, could you just comment on Llama versus the DeepSeek?
Yeah, I'd say that Llama is probably still the most popular model on our platform, and we actually do keep track of that, so we see that's true. Obviously, there's like some bias because we
Would you be
get
able to
like,
share a number? Is it like 70% or 50% of all fine-tune jobs or whatever?
yeah, I think it's probably like 60% or so of the fine-tuning jobs are Llama. I'd say that right now, the ones that are most popular, it breaks down between Llama and its variants and the Quinn 2.5 models. I'd say those two are broadly pretty popular. Llama has a big limitation, which is that its license is not actually completely open. There are some caveats about how you can use it and what you can use it for. And so in those cases, people who want just like, sure, I can do whatever I want with this tend to opt for the Quinn models because they're a bit more permissively licensed. But it's a trade-off there. I'd say that broadly, those two categories are pretty equally popular. But in terms of DeepSeek itself, do people have hesitancy about it being a Chinese model as opposed to Llama? I think that is, in my opinion, something you hear in kind of the mainstream media narrative about this, which is that the kind of geopolitical aspect is very important. But I would say that the popularity of Quinn, which is from Alibaba, which is, of course, a Chinese company, kind of speaks to the fact that, at least for practitioners, I don't think that part matters as much. I think they're more, what matters more to practitioners is really the license, is can I do whatever I want with this model? Are there any restrictions on this model? And then also the model itself, does it service my use case? Does it have some implicit guardrails on it that are prohibitive for my use case? Those are the kinds of things I see mattering the most to people in the industry that are trying to fine tune and productionize these models.
Yeah, I think that is quite surprising. I don't think people realize that Quinn has a slight head start to DeepSeek and has been able to. I actually am quite surprised that it has a double-digit percent adoption on at least on your platform. Is that? Do you think that it is a? Do you think they are maybe they should be more appreciated in the mind share of the practitioners who are considering a fine-tuning model?
Yeah, I definitely think Quinn is probably underrated in a lot of ways. One thing that I think is quite interesting is that if you look at the benchmarks for top coding models, you'll see, and this is not just open source models, like all models. So you'll see O1 and O3 and things like that. Sonnet, of course, but then I think something like number 10 on one of the benchmarks is Quinn 2.5, 32 billion coder. And it's like just this random open source model. It's not even like a huge model. It's a relatively small one, right? But it's a really powerful one. So definitely I think that Quinn models are underrated in my opinion.
Yeah. So I think part of the reason, as you pointed out, as to why people are so excited about DeepSeek was not just the performance and the cost, but also the fact that they were able to kickstart a self-reinforced loop where you get the aha moment. Could you just and also the fact that they independently verified that result, which kind of gives people the confidence that they can also do it. But like for this audience, would you be able to briefly explain how, like, what this RFT is, reinforcement fine tuning, and like why people in this field are so excited about it, why you believe that this could be potentially a game changer.
Yeah, absolutely. So I think that this all starts with this idea of like reasoning models and what is reasoning and from a perspective of LLMs. And I think that that goes back to O1 and Preview, which came out sometime last year from OpenAI, which was, as far as I know, the first model that was generally available that was a native, what we call chain of thought model. It's like a model that thinks before it gives a final answer, right? So it's basically prompted, or in this case, trained to generate tokens in such a way that it thinks step by step and kind of plans as opposed to just giving you a direct answer, right? And there's a whole body of literature that kind of suggests that for certain tasks, LLMs tend to do a lot better if they're thinking step by step and breaking problems down instead of just trying to give you an answer. Math is like a really famous one because LLMs are notoriously bad at doing math in their heads, which is when their activations are triggered. But math problems have this nice property that you can break them down into very small individual problems that then build up into a final solution. And so when you ask an LLM to solve a math problem one step at a time, it tends to do a lot better, right? And so that was the intuition behind this first class of reasoning models that came out. And so what made DeepSeek R1 particularly notable is it was, I think after O1 came out, we were all expecting someone's going to release a really good open source reasoning model. And what was particularly important about it is that LLMs like OpenAI that OpenAI's models that like provide you answers. This has been something that they've done from the beginning, and people were doing was taking the answers that like GPT-4 or whatever would spit out, and then doing what you call distillation on it to train a to train a model that's like comparably performant to an OpenAI model. And in general, I would say OpenAI and companies like that don't particularly like that because of the fact that obviously that degrades their role in the ecosystem if someone can just take their model and train a smaller model that does as well. So one thing they did with the O1 model was they have this chain of thought reasoning happening in the background, but then under the hood, they hide that from you. And then all they really show you at the end is the final answer. And so that makes it harder to distill the model because you're not able to see its thought process, right? So we were all waiting for, okay, when's someone going to release an open source model that is one, a really good reasoning model, but two, critically also, you can see that reasoning process by virtue of it being open, right? And DeepSeek R1 was really that moment, right? It was like other people had tried making reasoning models themselves. They all were not that great. R1 was a legitimate model, and it was not just a good open source model. It was like a really good model, period. Like it was very competitive with O1 on all the benchmarks.
So would you say
And
like
that's what I think
practitioners?
was different.
Oh, sorry. Yeah, just wanted to confirm with you. So to practitioners in the field, it was not a total surprise that an open source version or open source reasoning model that is at that level came out. You thought
Yeah.
it was like a matter of time.
Yeah, I figured it was only a matter of time until someone did it. I would say that if there was a betting market on it, probably people would have said Meta would be the most likely ones to do it, right? And as to how close it would be to the frontier model, like that was also maybe an open question. I think probably people didn't expect it to be quite so close to O1 in terms of performance. But then you have this open question of if O3 had come out a few weeks earlier and they were benchmarked against O3, would the benchmarks have looked as good? It's hard to say, but the reality is the timing worked out really well for them, right? Because they published their results very soon before O3 came out. And so when they stacked up against the current state of the art, they were very good. But for sure, I think it was a matter of time before someone did a really good open source reasoning model. And I think no one expected it to be DeepSeek. They had done some really good models before, like the DeepSeek V3 model, et cetera. But definitely this one took people by surprise. And what I think was particularly interesting about it to me was that they gave you the full recipe of how they did it too. They like in their paper were very clear and transparent about it. And to your point, like people were able to reproduce a lot of that themselves, right? Hugging Face has been working on a project called Open R1 that's trying to replicate it. People have independently verified that they can reproduce the so-called aha moment. And basically, they talked a little bit about that. What they said is that in the paper is that if you take a general purpose instruction tuned model, like in their case, they use the DeepSeek V3 model, and then you just prompt it to say, here are a bunch of problems, think step by step, solve the problem. And if you have a way of verifying those solutions to those problems, which we call like reinforcement learning with verifiable rewards, then you can give it very direct signal to say, yes, this was right, no, this was wrong, and then automate the process of refining that answer. And throughout this process, what the model eventually went to do was develop very organically, develop these novel strategies for solving the problem, right? And they called this the aha moment where they're like, oh, wait, I can actually do something different here, or I should remember this because it's important. And no one ever gave it explicit demonstrations of this. It just learned it on its own. And to me, that was actually the most interesting thing that came out of the DeepSeek paper. And since then has been reproduced. And then also, I think, was in large part the foundation of what we ended up building into our platform on reinforcement learning as well.
So let's talk about some of the commercial in an enterprise implications of replicate the fact that you can now replicate the DeepSeek R1's RFT process. So would you be able to give us a high level view of, okay, how can enterprises use this result to create their own company specific reasoning models, if that is even possible? And of course, you can talk a little bit about like how your platform facilitates some of that workflow. But before going into the weeds of that, like at a high level, like what would be some use cases that would motivate a company to train a custom reasoning model basically through the RFT process? And maybe give us like a very clear definition of what we mean by RFT.
Yeah, RFT is another name for this reinforcement learning with verifiable rewards process. The term was coined by OpenAI late last year when they were talking about a similar methodology that they used internally. And it basically just stands for reinforcement fine tuning. And the way that I think about it is it's a coming together of two different ideas. One is reinforcement learning, which has been around for a long time, and supervised fine tuning, which has also been around for a long time. And I basically liken it to it's using reinforcement learning to solve tasks that we would typically use supervised fine tuning to solve. And those are tasks that we would call objective or verifiable tasks, where they're like, is a clear right and wrong answer. And that's in contrast to subjective tasks, where it's more about preferences, human preferences about what is the right answer. And this idea of reinforcement learning for LLMs has been around for a while now. Like we usually call it reinforcement learning with human feedback, where the model gives you two different answers to the same question. The human's asked to rate that I like this one more than that one. And then that gives you that subjective preference signal to say, okay, do more stuff like what the human said was good and do less stuff like what the human said was bad. In contrast with reinforcement fine tuning, you're dealing with objective tasks like classification tasks or code generation tasks where the code has to execute and produce a certain answer. And in those cases, they're verifiable because you either have ground truth labeled data, like in the case of a classification task, you might have what is the label that I'm supposed to classify. Or in the case of code gen, you might not have labels, but you still have a verifier of some sort, which could be a compiler plus a unit test or something like that, right? So you can compile the code and you can run it and you can verify that it outputs what you expect it to output. So that's the fundamental idea of what reinforcement fine tuning is. And then in terms of where it can be useful and how it can be applied, so I like to think of it as I'm contrasting with SFT of like, where does SFT not work so well? And one thing we know for sure about SFT is that, or supervised fine tuning, is that it doesn't work very well when you don't have a lot of label data. Like it really is data hungry. It needs a lot of label data. And this is because fundamentally the supervised fine tuning process is like it is almost like a memorization problem where you're given a whole bunch of examples and you're supposed to figure out what is the underlying pattern to all these examples and essentially memorize them, but without what we call overfitting, where you don't learn like some general mechanism for how to output the right answer. You just try to mimic whatever the model does. So you're trying to balance between those two things. And so that means you need a lot of data, a lot of demonstrations to get it to really internalize anything meaningful about the problem. In contrast with RFT, you're never explicitly telling it what the right answer looks like. You're only giving it a reward signal to say that you are right or you're wrong, and how to what degree are you right or wrong. And then based on that, the model can adjust its own weights to try to steer itself more towards what gives it high reward and to steer itself away from what gives it low reward. And so that gives it the space to be creative and to come up with novel solutions because it's not being told like you have to answer this way. Rather, it's given the space to explore different strategies. And this is particularly important for reasoning models because reasoning models, of course, you're not just outputting like the final classification or whatever at the end. It's like there's this whole chain of thought that you need to generate as well, right? And so the question for supervised fine tuning a reasoning model is where are you going to get all of that reasoning data to fine tune the model? One answer is you can distill a strong reasoning model like R1. So you can say, here's an input, have R1 go and generate an answer. And then based on all of the answers it gives, if my task is verifiable, then I can reject all of the ones that are wrong and then keep only the ones that are right. And then I can fine tune a smaller model on top of that. And that works if you can generate tens of thousands, hundreds of thousands of such examples. But it also has a problem, which is that you're putting a ceiling on the total performance that the model can ever achieve because it's never going to be able to really do better than what the teacher model was able to do. And for some tasks, R1 is not the be all end all, and neither is any pre-trained model. Like in some tasks, you want to be able to learn to do better than any of those models, to be able to discover new strategies.
That's actually one just before I forget, like that's actually interesting because to create those samples to get that training data, you mentioned like using our DeepSeek R1, like a superior model to get those samples. But one thing that was a limitation is that perhaps OpenAI, the reason why they don't give us the raw chain of thought might be the fact that they want to deter that type of a behavior from the community to generate those, training samples, basically. Is that one interpretation of why you don't get an unfiltered chain of thought from OpenAI and some cosmetically summarized version of that?
Yep, that's exactly right. And in particular, I think they're worried about their competitors, right? They're worried about DeepSeek or someone else doing that. And it's understandable, right? It's like you put a lot of effort in a training model. You don't want someone to just distill it and copy it in a day, right? But it's a bad thing for businesses that want to be able to build their own models for custom use cases, right? And that's, I think, why open source is so important in that sense, is it gives you that transparency and that ability to do that. But yeah, so that's essentially the idea behind RFT is that you're able to explore different solutions to the problem. And for reasoning models in particular, that means being able to discover new strategies of reasoning that you might not have otherwise discovered that are more specific to the unique problem that you're trying to solve. But it's not just limited to reasoning. You can also think about it being useful for, say, code generation, right? Where you might have a reference example of code that someone's written. Code can always be faster, right? Like maybe the model could come up with a solution that's twice as fast as the reference example. And by giving it the space to explore that through reinforcement fine tuning, you can discover that, whereas you wouldn't have been able to do that with supervised fine tuning.
So the big catch here seems to be that RFT is designed mainly for verifiable tests, such as coding or math or protein classification or gene mutation prediction and things like that, which have been cited by the OpenAI's demo as well. But from a high level perspective, can't you just cast a lot of problems where there is some subjective valuation that you can do through using either LLM as like a judge for outputting like a score? For example, you might try to use RFT to train a really good writer, like a writing assistant, and you might give partial credit to essays that are not that great. Is there any way that you can cast a problem like that into a verifiable problem and apply it to train on domains that require a lot of subjective taste?
Yeah, certainly I think you can. I think that the one caveat to call out there, though, is that particularly for something like creative writing, you're leaning very, very heavily on the reliability of the judge model at that point, which is that you're basically saying, I trust the judge model completely to make a good decision about what is good and what is bad in this case. And maybe for some tasks that's okay, but for some tasks it might also be limiting, or it might push the model to a certain kind of style that's maybe very bland or very similar to what the LLM as a judge itself would have generated, which might not be what you want. So while it's definitely true that LLM as a judge is one way to have a reward function that you can use for something like this, it's worth calling out that there are some potential downsides just to be aware of. And the more objective the task is, in general, the more suited it is to something like RFT.
Got it. So, what are some of the verticals or vertical use cases that this could be today, but from now on, immediately be applied for you? Obviously, you mentioned coding and math, but from your customers, where do you see this being useful? And maybe this is like a good segue into talking about what features do you have planned for facilitating RFTs so that maybe even non-technical users can get involved in fine-tuning these things. By you said RFT is a very data efficient process, so maybe non-business people can supply some trading labels, and maybe the whole org can participate in the fine-tuning end-to-end workflow.
Yeah, absolutely. In terms of what we're doing on RFT, so use cases, I'd say the my favorite use case right now is definitely something like text to SQL or text to programming language, particularly for domain specific languages. I think it's just a really good fit for something like RFT, and it has like very real world value. So we've worked with a lot of companies now on those particular types of use cases. Other use cases that I think are very good fits would be traditional supervised fine-tuning tasks like classification and named entity recognition, but particularly ones that where getting good quality labeled data is difficult because it's very scarce, particularly in like legal domain or medical domain. You can imagine like cases like this, right? And those are good fits as well because again, like RFT doesn't have this overfitting problem as badly as SFT does, where it just memorizes and doesn't learn anything when you have small amounts of data. So those are, I think, like two broad categories that stand out. Another one that I think is very interesting as well is advanced reasoning tasks like hard RAG problems, so retrieval augmented generation. In those cases, we are starting to see chain of thought be very valuable for those use cases. There was some recent work on chain of thought RAG planning for planning agents and things like that as well. And that's another one where I think RFT will be very useful. And then maybe last I'd say is function calling. So nice thing about function calling is it's also a very verifiable task. So you can go and
Mm.
execute the function that the model selected and then verify that it does what you expect it to do. So those are, I think, all good candidates. In terms of what we're building into our platform, so we are working on building this as a generally available part of our product. So it's going to be a new reinforcement fine-tuning platform within Predibase. And the basic idea is that we want to try to have a very strong offering on three different fronts. The first is the managed infrastructure component. So be very fast, scalable, abstract away all the complexity of the different components that all have to interact and scale up and down and keep the throughput high so that everything's being utilized fully. But also, I think we want to have something very meaningful to contribute on the quality side as well. So one thing that we notice is that you have some data that you want to train on with RFT, and just throwing it all out there at once is not necessarily the most efficient way to get them all to learn. If you think about how a human learns, you don't teach it math by just being like, here's every math problem you'll ever need to know, and okay, go figure it out. It's like you typically think about structuring in such a way where, okay, let's learn basic arithmetic, let's learn algebra, let's learn geometry and go one step at a time. And we see something very similar with reinforcement fine tuning, where you want to teach it the basics and then help it learn over time to do more and more difficult things. And so that's something we're building natively into the product as well, is ways that you can think about what data to show and when do you show it throughout the training process to optimize the efficiency of the learning process.
Is it like kind of is it basically monitoring the loss and adapting how, or I guess what kind of data you feed into the RL? Is that what it is? Is like a adaptive training, or is it something different?
Yes, it's adaptive training in the sense that we try to monitor what the perceived difficulty of the examples of data is. And then based on that, we dynamically adjust what data we send to the model for training at any particular step so that we're not sending it examples that are too difficult until it's ready to do them and therefore wasting time and compute cycles, right? And then I'd say the biggest thing right now that we're going to be talking. So one thing that I think is very different about RFT from supervised fine tuning is that so supervised fine tuning is like all the effort is front loaded. You have to generate this big labeled set of data and make sure it's clean and that there aren't any errors in it and whatever. And that's pretty much all the work the user has to do. And then once the data set's prepared, you just upload it, you push a button and you get a model. And it's pretty simple. With RFT, it's a bit different because the data is not as big of a long pull anymore. It's like you can start with like 10 examples, and it's pretty easy to like hand generate 10 examples for any problem typically. So where the most of the time gets spent is on this part that we call the reward function modeling. And so this is the part where like you as a operator play the role of a teacher being given a student's assignment and being asked to grade it, right? Where it's, okay, the model generated this, what's right, what's wrong, where did it go wrong? And your job is to write a function or a set of functions that can score the model at any given point in time, right? This is the part that's supposed to be verifiable. And so what we do in our product is we let you see visually how the model's responses to a given prompt are changing over time and see that evolution of, okay, it started here and it was getting this part right. And then by the time we got to epoch number 10, it was generating this. And oh, it was starting to get the structure, but it was still getting this one part wrong. Like it was always using this one variable name that's the wrong variable or something. And then what's interesting from there is that it becomes an interactive process because then you say, all right, the model is struggling to learn at this point. I need to go back and I need to update my reward functions in such a way that I can fix that. I can get it to stop making that mistake.
Oh, so
So
there's
then
like a
you go in and make a
UI.
change to your reward.
Oh, sorry. There's a slight
Yes.
lag, it seems. You're saying that you can, during the training process, you can interact with the model's learning behavior through a UI, and you can see where it's repeatedly getting wrong, and you will be able to adjust the reward function on the fly, basically. And that reward function, the mental model here is that it is like a grading rubric. Is that you give like
Mhm.
X points to format, you give Y points to the correct answer. So you're actually your role as a ML engineer here is you're taking a more active teaching role. Whereas with the
Mhm.
previous techniques of fine tuning with SFT, supervised fine tuning, you're mostly focused on getting the best data possible. And you're spending maybe months collecting thousands of data points. Whereas now it's more like you could actually build like a UI and figuratively talk with the model where you're actively teaching it. Is that like a one interpretation of this process?
That's exactly right. Yeah. So that's the way that we envision it, is that you're almost like having a dialogue with the model where it's like, hey, is this right? And you get a chance to audit that. And it's obviously going to keep going, but at any point in time, you can take a look and see what it's doing and then go and make some modifications to that reward function to adjust. A really good example here is there's this in supervised fine tuning, we have this problem called overfitting that I've talked about, where it's like the model kind of just memorizes the training data. The corollary to that in reinforcement fine tuning would be something called reward hacking, which is where your reward function has like a loophole that the model learns to exploit, right? And a good example here is in one of our use cases that we did, we were trying to translate some source code from one language to another language. And the way that the model was learning to do this was it was writing the solution in the first language, and then it would have a function in the second language that did nothing, and then it would just return the answer. And that's obviously not what you want, is you want the model to actually solve the problem in the destination language, not in the source language, right? And so to fix that, we had to go and modify our reward function to say, hey, compare the output of the model both with and without the function in the other language. And if the outputs are the same, both with and without it, then it's probably hacking in some way. It's probably learning to exploit the reward model.
Models are getting smart enough where they can figure out shortcuts to hack through the process, and you have to actively, as a teacher, punish that type of behavior or at least monitor for it. I think this is a very different type of model training than pretty much like all the previous techniques that have existed in this space. At least to me, that have fine-tuned models before, I think this type of interactivity where you are actively engaged throughout the process beyond just looking at a tensor board, I think is very like it's almost like a UX problem.
Yeah, I was just saying, I think this is the feature we've done that has the most UX heavy component for that reason. And maybe one last point on this is you mentioned the non-technical user. Can like the non-technical user be able to do something like this? And right now, the limiting factor is the reward function, right? Is they have to be able to write this reward function. But they really don't, though. It's kind of the interesting thing because I use Cursor to do a lot of programming. I think a lot of people use tools like that. We've gone to the point with LLMs now where you can just say, write a function that does this, and then it's pretty easy to generate that function. So we're actually working on a way that you can specify your reward functions, not so much as just code, but just as natural language rubric, right? Say it must have this formatting, it must answer it in this way, and be able to translate into code on the fly dynamically. And in that way, like really open this up to non-technical users as well who understand the domain, but maybe don't know how to write Python code or something like that.
Like, what if your platform just suggested some very or reward functions like that you can compose together, like when you first are brainstorming how you should be structuring this reward function. So, for example, maybe you can just give or suggest like a rubric for this problem. I don't know how good that would be, but then it might actually reduce the cognitive load of trying to write the perfect reward function on the first time or something like that.
Yeah, I definitely think there's a lot of space for techniques like that. We are exploring kind of template style rubrics that we can have as well, like defaults that you can use for certain tasks. Here's how you grade a code generation task. Here's how you grade a named entity recognition task, right? Because I think a lot of these things end up being pretty standard, but definitely there ends up being a lot of nuance as well once you get into the weeds. So getting started, I think you can get started with like a very simple reward function that's just like one, it got it right, zero, it got it wrong. But once you start to see like where the model gets stuck, like where it's not progressing or where it's hacking, that's when I think it becomes like a more natural process to say, here's what you're doing wrong. Let's write a reward function that eliminates that. And so you build it up over time instead of having to think about it as like this solve problem that needs to be solved holistically up front, right? I think that's the big difference from
So,
SFT in particular.
so for RFT, you still need to start with a powerful enough model, at least to, especially if you're not having a lot of samples to fine tune, you still need to have a reasonably powerful base model because if you start with, let's say, like a 7 billion parameter model, you apply RFT to it, but it may not be able to be as sample efficient as, let's say, you're fine tuning like a 70 billion parameter model. Is that still the case? And also, is reward hacking and shaping the reward function the biggest sort of bottleneck to getting the performance that you desire, or is there some secret a bottleneck that people aren't talking about when we're talking about RFTs?
Yeah. In terms of the size of the model, the biggest difference I've noticed between the bigger models and the smaller models is often how quickly they get the basics of the problem, like particularly formatting and things like that. Like the larger models will get that stuff almost exactly correct from the very beginning, and then the smaller models might take a few more steps to get there. But they actually converge pretty well in a lot of cases, depending on obviously the task. But most ta of the time, the task is actually like for code generation, for example, is not one that you need a 700 billion parameter model for. You can actually do quite well with 30 billion parameter model or like 8 billion parameter model, depending on the complexity of the task. So I actually think still starting with smaller models is a good way to go. And then you can build up to larger and larger models over time if you're not getting the performance that you need. And then, yeah, I'm sorry, what was the second question? I
Yeah, the
forgot.
second question was in this whole process, what is now the bottleneck? If it's no longer having a large number of training samples, training data set is not the bottleneck, then what is the bottleneck? Is it the reward function and monitoring the training process, or is there something else?
Yeah, the reward function is definitely the biggest bottleneck, I'd say. That's where you spend like 80% of your time when you're doing this
Is it
work.
just like finger in the air right now? Like people are just guessing as to what would be a good reward function based on their vibe or experience, or is there a more systematic approach to this?
I do think that you start by being a little subjective and vibes based, where you might say, to your point, what criteria you have, formatting, compilation, successful output, but you're also responsible for weighting these things. And you might not know what is the absolute perfect weighting of these things in the abstract, right? So that I think is a little bit just more intuition than grounded in any practical scientific method or something like that. But that being said, it does become a lot more empirical once you start running the process, right? Because once you run the training process and you can see how it's learning and what it's not learning, then that gives you the feedback you need to go back to the reward function and say, okay, it's always making this mistake. It's always getting this wrong. Let's modify the reward function to get it to recognize that's something it needs to fix. So that definitely becomes where most of the time gets spent. There is also some time that can be spent on the data as well, because if your problem is too hard for the model to get even anything right at the beginning, then it can be hard to learn. So creating more simplified examples can help the model to overcome that initial hurdle of this cold start problem. And this is also an area where SFT can play a role too, is if you look at the R1 paper, going back to DeepSeek for a second, one thing they did was they bootstrapped the model by creating some number of really high quality reasoning traces and then fine tuning the model through supervised fine tuning on that before doing reinforcement learning. There's definitely a place still for supervised fine tuning in conjunction with RFT, and particularly in these cases where it's such a hard problem that the model doesn't even know how to start in terms of solving it, right? And so that can be something that requires a little bit of time as well. For very difficult problems, data can still be an issue in some cases. But by and large, reward function, that's where you spend most of your time.
So, yeah, I think what surprises a lot of people is that even practitioners, don't realize that there is a lot of model babysitting, even with the frontier techniques like RFT, and there's a lot of judgment calls for a field that is supposed to be very quantitative. Like even nowadays, I think back 10 years ago, people had a problem with deep learning because no one could really, people still can't really figure out how it works at a mathematical level. But now things are getting more high level with more and more abstractions built in. So I think it would be very exciting to see your product actually and just see what kind of interface you would be providing to make this workflow easier in some sense. One sort of a follow-up to that I had was that if an enterprise is supposed to start a fine-tuning project right now, and let's say they don't have a lot of data to do SFT, or they don't have like months to invest in getting all the training labels, and they want to try out RFT, what would be your top like five like use cases that you can think of that is generally applicable and maybe like domain specific as well? But what are some highest conviction use cases for getting like immediate results through RFT?
Yeah, definitely my highest conviction use case is any kind of text to SQL like problem. I think they're very common. And I think the reason is because a lot of companies have these domain specific languages that they develop internally, which are like
Could you
extensions.
give some examples of that? What do you mean by domain specific language?
Yeah, yeah. So domain specific language would be like I have my own internal BI tool or something like that we use for accessing all of our internal data. And so we wrote that, or like we work with some companies as well that they have their own domain specific languages that they use for their product for their customers to use. Right? This one's not like a Predibase customer or anything, but it's top of mind. So for example, there's Grafana as a company, and there's a
Hmm.
language called PromQL that they have that lets you query over your metrics, right? It's like they're a platform for letting you store and visualize metrics. And so they have a query language that they developed internally to be able to efficiently resurface those results. And that would be a good example of, I'm sure I would love a tool that's, hey, I just want these metrics. I don't really know PromQL. I want these metrics, so can you help me? And it will write the PromQL to then go and fetch what I'm looking for. So there are a lot of use cases like that.
I just had an idea. Maybe this model through RFT, maybe you guys can create something that writes open telemetry specs and like queries. I think that no one wants to learn it, but it's important. Yeah,
And
I
then,
just realized you were talking about DSLs, but yeah,
yes, exactly.
yeah,
DSL, domain specific language.
yeah.
Yeah, yeah. So exactly, I think there are a lot of these out there. Also, it's even frameworks. It's let's say you're trying to do an API integration with HubSpot or something like that, or whatever. Like there are lots of companies out there that have their own like SDKs and APIs that you want to integrate your system with their system. And rather than try to figure this out all out on your own and go and get on a call with their like solutions engineering team, like maybe you can just write a model that can do that for you, right? Like, or they could so that their customers can onboard more easily, right?
This is
Because
almost
that's a
like a
huge long
new
haul.
category of integrations, like a neural integration or something, right? You just feed in like an entire documentation or the schema, and then it just, to your point, like maybe all that. There is a lot of billions of dollars being spent on doing these integrations, right? And there's entire companies that do just this. If you frame it that way, I think it sounds really exciting, actually.
For sure. Yeah, I love the potential for this. And I think the thing about it is GPT-4 and all those models are getting really good at writing Python code and things like that. But they're still not really great at these more niche use cases because even though they can maybe go and find the documentation or whatever, they just haven't seen enough examples of it to really know how to write a good solution. But the thing is that these are verifiable tasks because at the end of the day, you can curate a list of common integrations and then you can write unit tests for those. And it's very easy to then just have the model start generating code, checking, running the unit test. Does it work? Does it not work? And if it doesn't, you just keep iterating until you eventually get something that works. And that's an entirely automated process at that point. So that's my number one use case. I think transpilation is another one. Like when I was younger and I was an intern, I worked on a lot of Fortran to C++ plus and like Fortran to Java type tasks. Those are super verifiable as well, because if you have an interpreter or compiler for one language and a compiler for another language, and you can execute both of them, then you can verify whether or not it's the
Like
same.
for this audience, can you like help us like appreciate just how much of a how big that market is? If you could figure out transpiling, how big of a deal that is.
Yeah, certainly. I think if your business has been around for decades, like you probably have some modernization efforts in place already, right? Where like, because the languages like that we use today are not the same languages that were used 40, 50 years ago, even 20 years ago in some cases, right? And it's not just always, complete overhaul of a language, but even if you're going from one version of Java to a Java version way down the road, like it's almost a completely different language. So certainly, I think there were a lot of problems like this that I've seen. And yeah, I would say there's still to this day a ton of code written in COBOL, a ton of code written in Fortran, and even some languages like C++ plus plus people are trying to move off of. So I would guess that this is, I don't know like exactly the
Let's
scope.
put a number to it. If you could modernize all the legacy code into the Python stack or whatever you prefer, like how much value would that be? Like that would be measured in billions? I don't know. Yeah.
I think so. Yeah, I think you also have to bear in mind the legacy maintenance costs for a lot of this stuff is very problematic because let's say that you have some COBOL developers who are in their 50s maintaining these systems. Younger people don't want to work on those problems. It's really hard to hire for them. Like COBOL programmers actually get paid a lot, I believe, because of this. And so as a result, it's like these people start to retire. Who's going to maintain these systems? Being able to modernize them automatically, like that's quite huge from just like a long-term health of the business standpoint as well. I definitely think there's a huge opportunity there. And then last, I definitely call out like the use cases that are more traditional supervised fine tuning, but where you don't have a lot of data. So classification, domain specific named entity recognition, and extraction. I think those are all use cases that we see a ton of. Tons of people that we talk to have these problems, but they just don't have a lot of labeled data, right? Because again, labeled data is like very difficult to curate. And there's a lot of opportunity to really move the needle for them as well.
What would be like the most oddball, like genius use case of RFT that you may have heard of in the last month?
So I thought of something the other day, and maybe someone will listen to this or go and take this and write a paper about it. But one idea that I thought was quite cool was We did this thing on writing CUDA kernels with using RFT, as I've learned to write CUDA kernels. But really, like when you're writing a CUDA kernel, what you really care about is you don't need to like necessarily generate a model that knows how to write CUDA. You sometimes just want to generate like one really optimized kernel for like attention or something like that. It's like people have spent countless hours trying to make attention faster. And so you can imagine having an RFT process that literally just has one example, which is the attention kernel. And you're just trying to optimize that like for hundreds of hours or something like that until you eventually discover the world's most optimized
Hmm.
attention competition, right? And you can make this a verifiable process because you can measure, does it produce the right output? And then how fast was it, right? And if the reward function is like measuring the speed, then like it's constantly trying to get faster and faster and finding clever ways to do that. So I think there's potentially some like creative things that you can do with this that could be very useful for science.
Would something like that make you optimistic about the ongoing reduction of inference costs? What is your view on that? Would the cost of serving models keep dropping like 5x every year, or is there some kind of a limit to this? I know that we have the test time compute paradigm now. What is your view on the how much juice is left in this paradigm, or are we just getting started? And for people that are skeptical about the ongoing progress, do you have any like sound bites that for that specifically?
Yeah, so I think the story about inference getting cheaper and cheaper, it's I know this is like an overused term now, but it's like the Jevons paradox problem where it's, yeah, inference is getting cheaper and cheaper, but that means we want to just do more and more of it. And so that's where test time compute is really coming from. And so we have this surplus of like inference capacity, right? So let's just like really like go crazy with it and spend weeks reasoning about a problem and to arrive at the optimal solution. So I think even if for a fixed amount of tokens, the cost of generating those tokens or the time it takes to generate those tokens goes down, the aggregate spend on inference is probably still going to go up
Oh,
just by virtue of the fact that
no,
do
I was
more and
actually
more.
approaching it from the angle of would it keep dropping on a per flop per the training run or per inference basis, not in the aggregate, but because of the techniques like RFT that can, I guess, run on a while loop and keep optimizing so every part of the inference stack. Are you optimistic that it will keep dropping?
For sure. I think it will. I think that it's hard to say exactly what will be the main drivers of that. There's obviously like a Moore's law type effect with GPUs that we're observing where every new generation is getting dramatically more energy efficient and faster and more capacity. And so there's an open question of the scaling laws there, like that go forever, or is it going to start to top off where, we can only do so much and the H8, whatever the next generation of like cars, the Z100s or something, whatever that ends up being, like, is it going to be orders of magnitude better? Is it going to start to become like the new iPhones where it's like, oh, it's okay, it's slightly better, not that big of a deal. So that I think is an open question in my mind. On the software side, I definitely think that there are optimizations. You're really fundamentally limited by the hardware at that point. So I think that my experience has been that we had a lot of really big optimizations in the first few years of LLMs with page attention and flash attention and things like that. But I wouldn't, I feel like on the software side, innovations have slowed down a bit on the inference side. I think at this point, I would say that there's not a huge amount of differentiation in base model inference, for example, between any company and like open source in terms of speed. Like where the speed benefits come from is through optimizations like the one we talked about with TurboLore, where it's like more unique to your data and your task. But just having like generic optimizations, I don't see anyone that's leaps and bounds better than the open source software stacks for that, right? And I think that's pretty telling that there's probably already a commoditizing effect happening there where they're all just converging to the same
Right.
basic solutions. But hardware is one where there's still a big disparity. So if you look at like the tokens per second that like Cerebras or Samba Nova or Grok can do, like there you can really optimize at a hardware level quite substantially and get big benefits. So I'm sure that there will continue to be like some innovations happening there for some amount of time.
Predibase started in the low code in the early days, and now you guys are a full feature flat platform. But now, like maybe with RFT, you might get a renaissance of low code ML, maybe do you see a future where you have vibe based AI researchers, as just like we have vibe coders these days, where you have like very powerful co-pilots? Do you see like that future as well?
Yeah, I think that was always like the killer feature of LLMs is like that you don't have to be super explicit about what you need it to do, or it's you can just do it in natural language and it'll figure it out. And that was the magical killer capability that ChatGPT brought to the table. So I think seeing that on the training side start to happen with RFT, where it's like more about intuition and less about overly technical fundamentals. I think that's a good thing because as long as the evaluation at the end of the day is still the same, it's still objective, and you can say, yeah, the accuracy is 99%. It doesn't really matter if you got there through being a data scientist and running these really complex like plots and whatever, or if you got it through this iterative process of telling the model, like, you got that wrong, fix it, and it got it right. If the result's the same, then that's great. We're already in an era of like vibes-based programming with Cursor again, where I spend most of my time just like typing Command K and then saying I want some code that does whatever and it figures it out. So I think that's directionally where we're going as an industry is relying more on human intuition and less on human precision, which is probably a good thing in general for knowledge work because we're
So,
actually
right, sorry.
no, that's it. Go ahead.
Yeah, so just wanted to, for those people who are interested in getting started with RFT, which I think people should really get their hands dirty with it and understand what it can do. I know you guys just are either in a beta or when do you guys plan on releasing this platform? Or are you still getting beta signups and things like that?
Yeah, so we're currently in closed beta. So anyone who wants to reach out and work with us, we're really excited to work with anyone on use cases they think might be a good fit. And that's something that we can also be hands-on and help with. And then we also are planning on releasing our first self-service feature around this within the next week or so. And then we're going to have a bigger launch of the full version of the platform, generally available in the coming weeks and a little over around a month from now. So is the target date. That's still on the that we're working on, but yeah, it's definitely something that's coming hopefully very soon is the full version of this with all the UX improvements that we talked about and the full version of this capability for customers.
And that the platform is planning on supporting any type of a like an open source base model for this purpose, or is it like limited to Llama or limited to DeepSeek or something like that?
Yeah, it'll be any model that we support on the platform will be able to use this. We'll have like first class support for the Llama models, Quinn, and DeepSeek distills initially, unless something else really cool comes out in the next few days. But yes, anything technically you can through the SDK use any of our models that we support.
So yeah, just to wrap up, like you've been at this for a while now in your entrepreneurial journey. What do you think is the biggest thing you've learned while being in the space in the AI infra space? And what advice would you give yourself back like 4 years ago when you just started out?
Oh man, I think there's a lot that we learned along the way about how to build a good product. But I definitely think the biggest learning for me has been initially we were thought a lot about building a product kind of in the abstract and not as much not and when we first started we thought this in the abstract makes a lot of sense. We didn't spend as much time listening to people tell us what were their problems. And now I think we are much better at that. Like we spend much more time as an organization just listening to customers and listening to prospective customers about what are you trying to do and what's painful, right? Like what is painful enough that you want to spend money to solve this problem? And designing the product that way based on what our customers are telling us they're struggling with is something that was a lesson that was hard learned, I think. For me anyway, being like a technical person, someone who came from a business background, right? So that's probably the thing that I would tell myself to do differently is spend more time listening to anyone in the space that you think could be your customer and asking them what they're struggling with.
And I think this is a good way to close this episode. What do you think is the number one pain of enterprise AI adoption?
I think that it's not good enough. The quality is not where it needs to be for production, and it's difficult to get the data into a form that can help get it there. That's the number one. Like we always talk to customers about like prospective features that we could build and stuff like that. And every time it always comes down to quality. It's like the model needs to be better quality. And they struggle to get the data. They struggle with labeling and all these other components, but ultimately it comes down to I need better models.
So I think that would surprise a lot of people because a lot of people think that we have AGI right now.
Yeah, and I think it's ultimately, obviously, I think like, Sonnet and models like this are amazing for their generality. But I think that when you're talking about a very specific application and you're talking about core infrastructure or like core IP, good or like 80% is not really sufficient for production in these situations. Like it needs to be nearly perfect or it needs to be as good as it possibly can be. Like every little incremental improvement drives millions of dollars in revenue. Like there are definitely use cases like this that exist for enterprises. So I definitely think that quality is the biggest problem, even in a world where we have really strong models that are getting better every day. Because in particular, these models are never going to understand your data as well as a model that you build custom for your enterprise will. And that's the inherent limiting factor always. So my view of the world is I don't think we're going to have a future where there's one best model that is just everyone uses it for everything. It's you're going to have a lot of models that are specialized to different types of use cases. And then you'll probably further fine tune those models to make them even more specialized to your particular use case because it's going to matter to you. Like every ounce of performance is going to matter.
So I think that's speaking to the importance of having the data and the labor to fine tune that process, whether it is RFT or whatever the future hot technique comes around. You still need the data and the love and caring of trying to get trying to squeeze out the extra performance, and that will always be evergreen. I think that's what you're suggesting here. There's not going to be like one model that rules everything, even if the GPT-7 comes out or something like that. It's hard to know yet.
Exactly. Exactly. I think that this has been true in all of every organization I've ever worked in is once something is critical enough to the business, like even the most minute optimizations drive disproportionate upside, right? Like we worked on ETA prediction at Uber, and they were trying to migrate from an XGBoost based model to a deep learning model. And they were trying to drive like 1 or 2% accuracy improvements, things like that. But it was a huge, massive migration. It took a year or more to develop, and it's moving from a very fast, small model to a much heavier, much more expensive to serve model. But like that small improvement in accuracy, like seemingly small, like actually drives significant seven-figure or more like revenue. Because if you get that, that changes the business. Like that improves all of the business metrics by just such a huge amount in aggregate.
I think that's super counterintuitive. And I think a lot of people are sleeping on this fact, really, is that when you have more and more powerful models that are general to everyone, that is available to everyone, then there's going to be even more effort trying to get a little bit more extra out of that, whether it's through fine tuning or having better data.
Exactly. What's if this is like the core of your product, right? Like again, like a Cursor or something. Like Cursor, like is trying to be the best platform to do code generation for for developers. At some point, you're going to realize that there's competition and there's other companies that are using the same models as you are. What's your differentiation? What's your moat? It's like your data, it's your ability to build models that are better suited to what your customers are trying to do. And so if you're not customizing these models for your business, um, you're commoditizing yourself, right? Like you're opening yourself up to competitors being able to just reproduce what you've done already. Definitely, I think the need to differentiate yourself by having custom AI solutions is just going to get more important over time.
Yeah, speaking of Cursor, I'm always shocked that they somehow became relevant despite the year of head start that Microsoft had. I would have never imagined that Copilot sort of losing the allure and the mind share among developers. If I were to like give someone advice like 2 years ago, what start to do, I would have not said do a coding assistant because it was the market share was like 90% get up Copilot, even in the enterprise. And I think it's a very important sort of example of how startups can compete because
Mhm.
it broke a lot of like assumptions of what we had. And I think that's even relevant to a company like Predibase because a lot of AWS and GCP have their fine tuning solutions right? But like Vertex AI, Bedrock, but there's always elements that like underserved needs, whether it is DevX or like in a model parity. So I would imagine like that is also relevant to like companies like you. From my perspective as an observer, it is hard to assume that large companies will not fumble the bag in some situations. I think that was the most surprising thing for me with the cursor example, but I think it's potentially relevant to you guys as well, right?
Yeah, I think that's definitely true. There are definitely a lot of people that have, when we started this company, there weren't a lot of people doing deep learning infrastructure. But now, obviously, there are a lot of companies that purport to do things like we do, whether that's on the fine tuning side or the serving side, et cetera. And yes, I think it's very critical for us to think about how we can win by being better at something very specific. So if AWS or GCP wants to try to be an everything for everyone kind of company, how do we be a something great for a specific type of person company, which I think what all great companies ultimately are, like when they start out. And so for us, like we want to be the best platform to help people build these customized models and get them in production. And I think that definitely means like thinking about it every aspect, like the efficiency, the user experience, the quality of the models that come out the other side. I'm thinking about that holistically. So yeah, completely agree with your point. And
Especially if RFT becomes as big as what we think it could be, and if RFT becomes like a very popular way for even non-technical people can get started in fine-tuning models, even with, let's say, 20 data points. I really think that maybe that is something that could be like a cursor thing where you have one use case. For cursor, it was like merging code. For fine-tuning platforms, it could be like this like RFT use case, and it could just blow up. And you just never know what's going to happen because it is such a new technology. And even OpenAI hasn't GA'd their platform, and everyone's wondering, what is this thing? So I think, yeah, I personally am very bullish on RFT, which is also the reason why I got in touch with you guys. But maybe like we can close this by you predicting where RFT is going to be at the end of this year and where your product could be, and maybe give us like some goalposts to strive for.
yeah, my hope for this year is that we see RFT be used to train a state-of-the-art like specialized model in some domain, like whether that's CUDA kernel generation or something else. Like I would love to see this become like a recognized approach that solves this problem and like particularly be able to show that it does it in a very sample efficient way. And then in terms of the goals for our product, yeah, we want to launch our reinforcement fine-tuning platform generally available. And then my hope is that we can continue to improve upon that to the point that we can lower the barrier to entry to that non-technical user as well, so that this becomes just something very intuitive and very cursory in its ease of use and ease of adoption. So those would be my goals for this year.
Okay, Travis, thanks so much for talking to us and being so generous with your time. Really excited to for the release of your product and also for anyone who's interested in signing up for Predibase's RFT beta. I think we'll have potentially something from Predibase, but so stay tuned on that. Anyways, thanks a lot, Travis.
Thanks, you too, John. Thanks for having me. Bye.
All right.